going to show you over the robot, the club robot at the Dallas Personal Robotics Group. His name is Tankbot. He's shortly to be passed on to a new owner, so I'm going to tell you the things that he can do now, point out some of his major components, and demonstrate him doing the best that he can.
Up front we have two motors, one for each track, and behind the motors the drive electronics that powers them. Above that, a forward-looking sonar for obstacle detection and another sonar mounted on a servo. Tiny Cylon with the flashing LEDs, microcontroller for driving the motors behind that, and an Arduino with sensor electronics, an ITX PC motherboard with running Puppy Linux, and a monitor behind that.
My fellow club member Ed Paradis started Tankbot and built it from what used to be a toy tank into something that is now quite a respectable robot. He handed it off to me about a year ago, and I took it, added a whole bunch of components to it, and enhanced his software, which was still very much the foundation of the robot, and got it to compete successfully in some of our robotics contests here in the club.
So some of the first things we did was take apart all the tank pieces and paint it from its normal camo color to kind of a metallic sports car red, because we wanted to kind of take a bold color statement. Steve and I spent months and months painting it with primer and then multiple coats and then a gloss coat, and it's probably a lot of time spent on that. And we also upgraded the drive system from the original simple motors to some gear motors with encoders on it. Steve was. We also put on some motor controllers from New Micros that were donated, and started with some sonar units so that we could tell distance. And probably the first thing the robot could do successfully on its own was a wall avoidance program that ran on an Atmel that I wrote, that ran its logic off of a little laptop stuck on the back running Perl. And that won Best of Show in one of our earlier competitions, so that the Tankbot's got a glorious history of winning competitions.
Tankbot uses an Atmel microcontroller to run the motors and the encoders, and Ed wrote all the software for that. It hasn't been changed since, and then that receives higher level commands from the software running on the running Linux on the embedded PC board. Tankbot also has a Arduino board on it that runs the sensors and feeds the sensors back to the Linux board running the higher level software. We mounted an electronic compass on Tankbot on top of a pylon to keep it away from the metal components and motors, other things that change the magnetic field. And the compass runs back to the Arduino board that regularly reads the compass and feeds its data back to the program running on the Linux ITX board.
We used to have Wi-Fi on the robot with an entire wireless router just stuck on the back as an access point that we connected to using Ethernet from the embedded computer, and then we've done some other wireless experiments with it.
Yeah, Jason Oliver donated a Wi-Fi dongle that happily Puppy Linux recognized, and so now Tankbot connects to whatever Wi-Fi network it finds itself in, and we just can log right into Tankbot using VNC desktop takeover and run the programs right on the robot. Tankbot's about to do its last successful maneuver in the Roborama competition that we're call it the square dance. It runs in a square around some cones. It uses the electronic compass mounted on top of the pylon for navigation around the cones. The compass is read by the Arduino microcontroller, which is feeds it back to software running on the Linux system on the embedded PC. It also uses distance data fed back off of the tracks from the motor encoders to figure out how far it's gone before it should turn. Tankbot's equipped with a USB webcam, which we just need some software installed to make it work. Tankbot has sonar sensors front and back and a steerable sonar. Front sensor, rear sensor, and this sensor is mounted on a servo which we can sweep around so the Tankbot can look ultrasonically for obstacles that might be in front of and to either side of it. It also has one of Dale Wheat's famous tiny Cylons to ward off bugs and enemies. One last thing that we put on Tankbot was a monitor, kindly donated by Dale Wheat, which shows the desktop for Puppy Linux. It gives you a rough idea of what's going on, and you can tell whether it's booted, but really desktop takeover is the right way to use it. However, in a pinch, you can plug a mouse and keyboard into the PC board and use the monitor to reboot Linux if it crashes. Okay, we're going to make it go around in a square now. Tankbot is steering using his compass, and you can actually see him turn a little bit left and right as the tracks drift off of center. And then you can see him turn by running one track forwards, one track backwards, and then he turns until the compass reading indicates he's going in the new direction. And there you have it.